صح
غلط.
غلط ليه؟ الفريزر ما فيش ايس كريم؟
وشبت يعني
Okay, last time we already get to the operation amplifier. Okay, so I just quickly go over for the operation amplifier. So the first thing you have to understand is you get the open loop gain and the closed loop gain. Open loop gain AOL will be equal V out divided to the VD. VD means the voltage difference zone at the input, and VD equal V at the positive minus V at the negative of the op amp. And the open loop gain normally they can be 100 to 100,000. That will be coming out from the manufacturer. Okay, then you can go to the inverting amplifier. We call it inverting amplifier. That means input applied to the negative input of the op amp. Okay. I try to see quickly. Okay, this is the one. Okay, let's see. Inverting amplifier. Input applied to the negative. Output will be round. And you must understand this point here we call a virtual round. Okay, that means the 0 volt. And the gain of this amplifier equal minus R3 divided to R2. Okay, and also we already know the current coming out from the input, they go in this way. However, they cannot go in down. They will be go into the op amp. And also you get another current from the load go to into the op amp. In this case, there will be a sink current. Op amp pull the current in. Okay, and if you want to calculate the current, okay, and easy for you to know how to do calculation, and also you want to calculate the V out, okay, then you know how to do it. That already done. And now if you apply the AC voltage to the inverting, so same thing. Whatever the same thing, that means you can get the gain ACL. That means closed loop gain. The reason they get a closed loop gain, the thing is they get a feedback register here. Okay. And only thing they can telling you, if you get the input, you get the gain, you're able to calculate the output. And the input and the output will be opposite. That's why they call it inverting. Okay, if you get any questions, please stop me, okay? And now you can get another, will be a non-inverting. Non-inverting, that means the input applied to the positive of the op-amp, okay? And that's what they call a non-inverting amplifier. And the gain will be equal 1 plus RF divided to R1. So that will be telling you the gain of the non-inverting on the time must be higher than 1 adding something. And if you want to calculate the V out, you take the gain times the input, okay? And also in here, they given you more detail how to do any calculation, okay? You have to review it. That's just a very, very basic, okay? Next one, they're talking about, you can see the different way for the non-inverting. That means the different to build the circuitry. For this circuitry, input apply positive. Okay, that's what they call non-inverting. And the gain, okay, we already got the gain equal 1 plus RF divided RI in this schematic. Okay, and if you want to calculate the V out, if you get a V in, take the V in times the gain, okay? And if they add the current go to this resistor here, RI, then you understand the V in and the V in at positive input and the V at the negative input, they will be the same. So you can take that voltage divide to this resistor, you can get the current, okay? The next op-amp you must know that will be unity gain amplifier. That means the gain of this amplifier equal to 1. And also they get a different name for this circuit, like a buffer amplifier, isolation amplifier, or the follower, okay? Then, now we go to the summing amplified circuitry. That means at the input, they're using the inverting amplifier. Input, they get a one source V1, V2, V3, and more, doesn't matter. So, to calculation, to get the V out, and the V out finally will be equal minus of total input voltage V1 plus V3 plus V2 plus V3 and more. Okay, that's the summing amplifier. And this what they're talking about, the maximum rate gain of the output voltage in response to the step input voltage is what they call a slew rate. Okay, that only telling you when you get the input going 0 from negative to positive, and the output supposed to be the same. However, they cannot be the same. They take a little time, okay? to get into the output. That's why they need to calculate the slew rate. The slew rate depends upon the high frequency response of the amplified state within the op-amp, and the definition for calculation slew rate equal delta V out divided by delta VT. Okay, this is the delta VT. That means from a 0 here, go to whatever they coming out. That delta VT. Okay, and delta V out will be equal plus V maximum minus to minus V maximum. The unit of slew rate is volt per microsecond. Okay, so basically output supposed to be go exactly the same. Input, the thing is just a follower. However, they not. They take a little time in order to can get into the maximum V out. So the time between minus V maximum up to the point they go up here, that we're talking about a delta T. When you do an example, that means you can understand a little more right here. The output voltage of a certain op-amp appear as so in the following response to the step input. They want to know what is slew rate. Okay, so you can see the solution. The output goes from lower to upper limit in 1 microsecond. That means they going from 90% of minimum to the max 90% of maximum. You get a total 10 volt. Okay, 90% you get a 9 volt and minus 9 volt. So from minus 9 volt up to plus 9 volt, that is the time. Okay, what they given 1 microsecond. Okay, and if they want to calculate the slew rate, okay, let's see, they say right here, the limits are taken at the 90% point as indicated. So the upper limit is plus 9 volt and the lower limit is minus 9 volt. Then the slew rate is delta V out divided delta T. So basically they're going from 9 volt minus to minus 9 volt. Divide to the time 1 microsecond. So basically you get 18 volt per microsecond. Only thing is what you need to do. You have to go through the example, redo it, make sure you understand how do we calculate the slew rate. And also they given you the example related problem here. Okay, so you can do your calculation. Let's see what else. Gain bandwidth product. That will be an increase in closed loop gain caused a decrease in the bandwidth. That's only telling you when you try to get a higher gain and the bandwidth will be decreased. Unity gain bandwidth equal ACL, closed loop gain, time FC. Now, determine the bandwidth of each of the amplifier. So both op-amp have an open loop gain of 100 dB and unity gain bandwidth is 3 megahertz. See how they do. For non-inverting, this is non-inverting. The closed loop gain ACL equal 1 plus RF divided RI. So they get 67.7 FC, okay? That's a bandwidth product equal unity gain bandwidth divide ACL, okay? Unity gain bandwidth, they given you 3 megahertz. You divide 67.7. That's what you get that for bandwidth product. For non-inverting amplifier on this one here, okay, you can calculate the gain is minus 47. And unity gain bandwidth divide ACL, okay? So you get 3 megahertz divide 47, you get 63.8.
Mr. Pam, a question.
Yeah,
On that first schematic, the one on top, it's got a wire going from between the two resistors to the minus. Now, there's no resistor there. Is that there's no feedback, or how is that treated?
that's a feedback.
Even though there's no resistor there?
Here?
Yeah, right. There's no
No,
resistor.
no, no, no. No resistor here.
But it's still a feedback.
Yeah, they connect from the out to the in. That's the feedback.
Okay. All right.
Okay, and another one, differential amplifier. Okay, differential amplifier, that means they apply input voltage to input negative, voltage input to positive. That means they get input for negative input apply to negative input of the op-amp and also apply to positive input. That's what they call a differential amplifier. Okay, and we already telling you for this circuitry R1, R2, R4, R5, R1, R2, R1, R2, R4, R5. Okay, the same value. Then the different amplify subject V1, V2. Okay, Vout will be V2 minus V1. Okay, let's see. You understand for in this situation, if you want to calculate the output, then you have to solving the problem one by one. First thing, you have to round V2, okay, and calculate for V1, what the gain. So that if you round on the positive and you apply V1, then the circuitry will be inverted, okay? Then you can calculate the gain of the inverted. And also you can calculate the Vout1 of the inverted. Then you rounded V1, calculate the voltage again for positive input, and now they will be non-inverted. Okay. Normally, after you doing your calculation V1 and V2, you add them up, you can get the output. But that is basically for solving for differential amplifier. Okay. Round one input, calculate the other, and round the other, and calculate this one. Add them up. Okay, last time we already done this thing here. Okay, we have to get through it. Let's see. Common mode input voltage. Common mode input voltage appear A, across the inverting or non-inverting input of differential amplifier, across both input of a different amplifier. What do you think A or B? You understand a common mode. Common mode rejection ratio. That means when both input get exactly the same voltage, same frequency, that considered to be the noise. Okay? And the op-amp supposed to be cancel that noise. That's what they call common mode rejection ratio. So now the question is common mode input voltage appear across the input or non-inverting. B, across both input of the differential amplifier.
B.
Tell me A or B.
B.
B, correct. They must be the same on both input of the differential amplifier. Okay, that one we already done that. One, let's see, something else. Okay, so basically that they just given you more detail, okay, for this circuitry here. And basically when you're doing your left volt, you will be go through this thing, okay, again. Now, in this circuit, S1 you to switch V2 or V1 into the circuit V out, into the circuit. Then V out, A vary between 0 plus 10 volt, is essentially 0 for either S1 position, vary between 0 and minus 10 volt. Both A and C depend on position of S1. So basically they can move this to V2 or they can move to V1. Okay, what happened to the V out? For your understanding, telling me A or B or C or D.
D.
Right now, they on V2. What output?
Zero.
0, correct?
Yes.
The thing is, when they connect to V2, V1 equal V2 and input positive V2, input positive also V2. That means identical signal, supposed to be the noise. Okay? And the op-amp using common mode rejection ratio, they try to cancel that signal. They want the output to be 0. So A or B or C or D?
B.
B, correct. B is essentially 0 volt for either at one position. You see that? That is the answer. Now, that they will be telling you only one thing. When you want to apply the input to the differential amplifier, and both signals must be opposite. Okay? They must be opposite. One going down, the other one have to be going up. Okay? That's only the key point for you. Now, on that one, based on the circuit information, VO equal
C.
Okay, you get 2 volt here. You get 2 volt here. But that 2 volt here apply, then you have to know what the voltage here for non-inverted. Okay? V2 is not a direct input, must be connected to direct to the positive. So basically, at this point, you get 2 volt here, then the point right here, 2 times 10K divide 10K. So that one, they will be get 1 volt. Okay? So this is a 1 volt. And if you want to calculate the V out, okay, for V2 input here, what is the gain? Okay, input V2. The gain ACL equal what?
1.
Who telling me? Okay, I can write down here, I can see it.
It's 2.
Perfect. Input V2 ACL 1 plot, right? 10K divide 10K. Divide 2. And V out 2 equal the gain times the input here. Gain equal 2 and the input here equal 1 volt. So that's why equal 2 volt. So now if you're talking about input V1, ACL equal what?
-1.
Yes, -1.
Perfect. Minus 10K divide 10K equal -1. Okay, so VO1 equal -1 times 2 volt. Okay. So output equal V out 2 minus V out 1. What do you think, A, B, C, D?
It's B. Should be 0 volts, B.
Okay, V out equal what? V2. V2 equal 2, right?
2 minus 2.
So it's C.
Exactly.
Hey, Mr. Pam, just a quick question.
Yeah.
On V2, you have the two resistors, 10K, 10K, and you got the 1 volt at that node because that's a voltage divider. Is that correct?
Correct.
Okay, thank you.
That's a very, very basic circuitry, not too many things, but we're asking for know how to solving that problem quickly. First thing you try to understand, and you have to exercise, okay? Otherwise, for a while, you forget everything. This is the answer here. Okay, so that will be done for operation amplifier. If you get the time you want to reading or textbook, I don't care. But at least this handout, you have to keep going over and over. You can get better understanding, okay? That's really only thing need for you to be a technician, okay? Today, I go with what we call active filter. You understand the filter we already done last summer. That's what they call a passive filter. And today we will learning exactly the same way they working, what they call a active filter. What a difference. Passive filter, that means they're using the RCL. They don't need any DC power supply for the filter circuitry to working. That's what they call passive. And now, even the filter working the same thing. However, they're using the op-amp to build the filter with I and C. And op-amp, they need the DC power supply. So that's what they call active, okay? And this is a very, very basic thing. Anyone learning electronics, you have to know the period, T. In order to get the frequency, you have to using F equal 1 over T. Okay, so that's why you can see that's what they call a time domain. Time. Equipment using for time domain will be oscilloscope. Oscilloscope is the time domain, so they cannot measure directly frequency. Okay, the thing is, they can asking you very simple question. Can we using this oscilloscope to measure the frequency? The answer must be no. Okay. The thing is the time cannot get the frequency. You can say, okay, I can measure the period. Then I using the formula F equal 1 over T to get the frequency. Okay, and now another one. You get a lambda here. and this will be a distance. Okay, lambda will be a wavelength equal V divided to F, and V equal 3 times 10 power 8 meter per second. F will be in hertz. Okay, that's just telling you the signal, like the period, take how long in the space. That means that this the wavelength will be the signal occupied the distance in the space. Okay, and now let's see what they want here. For this amplifier, the gain equal 1. You get input 10 volt. You get output 10 volt. AV equal V out divide equal 1. AV equal in dB. You take 20 log of 1. You get a 0 dB. That's only telling you one thing. When you get a 0 dB, that means you get a no loss. Input, output will be the same. Okay? So that's why if you calculate by numerical, you get a equal 1, V out equal V in. However, if you want to calculate in a decibel, and the decibel will be 0 dB. Okay, so make sure you understand 0 dB means no loss. No loss means input, output will be the same. However, if input 10 volt, output 5 volt, you lost 5 volt. Okay, then now they said at the critical frequency, what the V out. You understand, try to memorize critical frequency. They can say this is the break frequency. Also, this can be corner frequency. That means they get a different name, but they get the same thing. Okay? At the critical frequency, the output will be going down 0.707. That means 70.7%, okay, of the input. So if you get an input 10 volt, at the critical frequency, they going down 0.707 or 70%. You take V out times 0.707, you get 7.07 volt. Okay? And what V out at minus 20 dB? Okay? So, see 10 times 0.1. Why 0.1? Who knows? Right here. Input at 10 volt.
Is that like 1 decade or something? Is that like minus 20 dB decade or something?
Exactly. The thing is, when they're talking about dB, you cannot do anything with dB. You have to know what the numerical of that number. Minus 20 dB equivalent to 0.1. Minus 40 dB equal to 0.01. Okay? And what is the equivalent to 0.707? What dB equivalent?
Minus 3.
Minus 3 dB. So that's why normally they're telling you at the critical frequency, output will be going down 3 dB. When they're talking about minus 3 dB, you cannot do any calculation. in order to get the output value, you have to understand a minus 3 dB equivalent to 0.707.
So, Mr. Pham, like all these, like you're saying, like for minus 20, minus 40, minus 60, we have to remember like 0.1 or 0.001 or 0.0,
Exactly.
so forth and so on.
Right.
That's a memorization thing.
Right.
Okay, thank you.
The thing is, when they say about minus 3 dB, you don't know how can we get the output from minus 3 dB? Then you have to find out what the number equivalent to minus 3 dB, that will be 0.707. We're using that number. Same thing, minus 20 dB. You have to find out what the equivalent to minus 20 dB. That's a 0.1. So you can see the difference. When they're talking about dB, when you need to do in calculation, and when you calculation, you cannot using dB in calculation. You must know what the number equivalent to that dB. Okay, make sure if you get any question, okay, stop me, let me know. Now, that will be given to you. I get square wave here. Okay, that's a square wave. And basically, the square wave be made up by the sine wave. Okay, this is the sine wave at the different harmonic. First thing they telling you, I get the fundamental 1 kilohertz right here, for example, the big one. And second harmonic will be 2 kilohertz. Third harmonic will be 3. Okay, and normally they're using the odd harmonic, not even. Okay, so the more harmonic will be turned out to be square wave. So a square wave is made up of fundamental sine wave and infinite number of odd harmonic. Okay, so if you get a 1 kilohertz fundamental, then third harmonic will be 3K, fifth harmonic is 5K, and so on. Okay. Now you can see this is a square wave display on oscilloscope. Okay, and they given you the period 1 millisecond. They're telling you using F equal 1 over T, you get the 1 kilohertz square wave. And you can see this is a minus volt, 1 volt, this is a positive 1 volt. Okay, if you're looking at square wave in your oscilloscope, you can see exactly the same. However, now this is the T time domain. That means the signal will be displayed on oscilloscope. And then we're going down here. Okay. Frequency domain. Frequency domain will be displayed on spectrum analyzer. That's right here, spectrum analyzer. Okay, this is a frequency. So even to get a square wave or sine wave, okay, in the spectrum analyzer, you cannot see like on the scope, okay? Spectrum analyzer just telling you at a certain frequency what the voltage at the output. For example, at 1 kilohertz, you get the amplitude 0.9 volt. At 3 kilohertz, you get 0.3 and so on. That means on the spectrum analyzer, they just show you at a certain frequency, okay, the value of the signal, like sine wave, square wave, okay, round wave. You cannot see the same like you see on the oscilloscope. Make sure you understand that. In here, they say fundamental, okay, 1 kilohertz. Third means maybe 3 kilohertz. Fifth, 5 kilohertz. And keep going, okay? Now, I get the question here telling me basic definition for the bandwidth. What bandwidth equal? Just the basic definition. Come on, tell me. Or you don't know.
F2 minus F1, upper minus lower.
How come I still memorize and you guys not memorize? I believe I already get it done. Not the one semester, but a different semester. And when I try to asking you and you still not telling me exactly what we wanted. What is the bandwidth by definition?
Is it bandwidth equals FH minus FL?
Just say F in
FH
F,
minus
F out.
FH minus FL.
Now, and also before I go to that, I asking you.
Are you saying bandwidth is the distance by which you can operate on one or the other side of the main of the corner frequency or whatever?
No. Okay, now
It's
before I can go back to that one, I asking you, what is the bandwidth?
the frequency you want to tune your radio to.
It's the frequency upon which you can get the signal without any noise.
No. Very simple thing.
Minus 3 dB.
No, nothing to do with minus 3 dB.
Okay.
It includes the carrier.
Is 1 kilohertz, right?
That is the question. But I want to get to definition, basic definition. When we're talking about bandwidth, what the bandwidth equal?
Cutoff frequency.
Okay, please write down.
F min.
Try to remember, I already talking to you. The bandwidth between the difference between the maximum frequency and minimum frequency. That's a general definition.
Hey, Mr. Pham, one of the students already said that.
Yeah, I think I did say that. So
Okay, sorry.
FH stands for high frequency and FL stands for low frequency. Am I correct?
And it's the difference between them.
Yeah.
Okay. Okay, then. Yeah, I did say that. I just said it in a different manner.
Okay. Then what is the bandwidth of 1 kilohertz sideways?
2 kilohertz.
One answer will be 2 kilohertz. Who else?
What's the bandwidth of 1 kilohertz? It should be 1 kilohertz. Wait a minute. What's the bandwidth of 1 kilohertz?
1 kilo.
Here's 1 kilo.
Yes, 1 kilohertz.
You can see the sideways on the oscilloscope. So what is the bandwidth of that 1 kilohertz?
1 kilohertz.
Okay, tell me, okay? F max equal
1 kilohertz.
1K. F minimum equal
0.
So 0.
maximum 1K and minimum also 1K. They get only one. So the bandwidth of 1 kilohertz will be equal 0. So that will be telling you with the scope you cannot find the bandwidth. The thing is that the time domain. Oscilloscope only show you either 1 kilohertz signal only or 10 kilohertz signal only. You cannot get different. When you get a different, then you can take a maximum minus a minimum.
So, Mr. Pham, are you saying that if you ask the bandwidth of 1 kilohertz, actually you need to give us two things, but not one thing?
Then you have to get a maximum frequency and you get a minimum frequency, you get a different.
Okay.
However, on oscilloscope, they display 1 kilohertz signal, only one kilohertz. You cannot get another one. So that's why the answer will be 0. Very simple thing, a oscilloscope using the time domain. You cannot get any bandwidth. Bandwidth are different between maximum frequency and a minimum frequency, not the time. That's a tricky question. Okay. Now, when you go to spectrum analyzer, this is a spectrum analyzer, okay? They display 1K, 3K, 5K, 7K, okay? So basically, this is a 1 kilohertz signal, okay? And they will vary with the frequency. So they can ask you, what is the bandwidth of this signal at 5 kilohertz. Then you can take the maximum is 5K minus to 1K. That's why you get 4 kilohertz. The thing is, this is the frequency domain. You can do calculation. And they keep going, 7, 9, 11, 13, 15, 17, keep going. However, recommendation for technicians, that means if they want to calculate the frequency of the bandwidth, then normally you calculate up to maximum a harmonic 13. Don't try to go higher. The thing that you must be understand on the basic thing happen in the spectrum analyzer. If you want to working on that spectrum analyzer, most of the big company in San Diego own defense company. And defense company, normally they working regarding to most of the thing could be communication. Okay. And the communication, they have to be using spectrum analyzer to measure everything. So that's why in this program, okay, I have to bought it. One spectrum analyzer cost you 24,000. So, got too much. I'm lucky. So that's why at the time I get the budget, I can bought what happened in my company while I'm working there. So that's why I want to train it for you guys. Yeah. Okay. You can say a 1 kilohertz square wave, 500 millivolt per division, 200 microsecond per division. That's telling you the voltage peak to peak and also a time period. And you can calculate the frequency. So on oscilloscope.
Mr. Fan, can you move your page up a little bit, please?
What?
Can you move your screen up, please?
Up here?
Thank you.
Okay. So this is a square wave. Display on oscilloscope. And the same thing. Square wave will be displayed on spectrum analyzer. Okay. So the first thing is here, that 1 kilohertz fundamental. Okay. I think I did a 1 kilohertz. And after that, third harmonic will be 3 kilohertz. Okay. Next one, 5 kilohertz. Next one, 7 kilohertz. Let's see. That will be 3, 5, 7, 9, 11. Okay. So 11 harmonic. So you can see on a spectrum analyzer, they just telling you at a certain frequency what the amplitude they get. Okay. Okay, and the question up to this point.
For the best signal result, the lower the harmonic is better.
That means they tell you what the frequency. right here, 1K, right?
But isn't that also describing the noise?
No, it's not talking about the noise here. They're just telling you at the harmonic frequency, what the value.
And that's it. They're in most industrial standards, they're only using the scale up to 17.
Normally, they up to 17 kilohertz. That's too much. They can go more, but normally for technician, they want you to calculate anything up to 13 harmonic.
Is your grandpa still up there?
What?
Okay, cool. Need to give him something.
Okay, so I just bring it up to you two things. One signal will be on oscilloscope that really get along with you when you're working on the lab. And now another one, same signal, will be show up on the spectrum.
You didn't kiss my forehead. You didn't kiss my forehead. Grosera.
You need to mute.
Okay, and the second one show you the signal, same thing, will be displayed on the spectrum analyzer. Okay, filter. Filter are circuit that are capable of passing signal with certain selected frequency while rejecting signal with other frequencies. This properly called selectivity. Okay, so basically filter allow a certain frequency to pass and block another frequency. Active filter is transistor or op-amp combined with RC/RL, RCL circuit. The active device provide voltage gain and the passive circuitry provide frequency selectivity. So you understand that using the op-amp to build a filter. And when the op-amp, they can be inverting and inverting follower. You can calculate the gain. And also they get the I and C in the circuitry they call a passive circuit. That will be given you what the frequency you wanted. The four basic categories of active filter will be low pass filter, high pass filter, band pass filter, and band stop or notch filter. Exactly, we already learned it, okay, from passive filter last summer, okay? So if you really understand in the last summer, then that's more easy for you to understand on the active filter. Okay, this is a low pass filter, ideal response. That means you start from 0 and up to the cutoff frequency. That's what they call a bandwidth. Okay, this is the one ideal, but it's not using. We're using practical output frequency, you know, the low pass. So basically, they display AV here. Okay, AV means the gain. The gain equal V out divided to V in. And in decibel. Okay, now at this part right here, if I given you the example, I get FC is 1K. FC. Okay, so at this point here, what the gain equal? That means less than you can get a 500 hertz, 100 hertz. What the gain equal?
One.
Perfect. Wow. The thing in here, they say 0 dB, right? 0 dB means 20 log of 0 equal what? Now, also, I want to know what they call in here. What the name? You remember that one? Mid-range. So that means at the mid-range, the gain equal 1. Gain equal 1 only telling you input output will be the same. And when you go to the cutoff frequency, at this point, I've given you 1 kilohertz, for example. Output now will be going down 3 dB. See that? However, going down 3 dB and you understand at the critical frequency, but you want to calculate it, you have to take the input time 0.707 in order to get the value of the output. And also they will be telling you the bandwidth of this low pass filter will be from a 0 here, go up to maximum will be FC. That is the bandwidth of this low pass filter. After the cutoff frequency, whatever output, we don't care. Only they care up to cutoff. So basically the bandwidth of the low pass filter will be from 0 hertz up to FC. And then they said slope. That means the one that keep going down equal minus 20 dB per decade. What that mean for minus 20 dB per decade? Who understand telling me what that means? They said minus 20 dB per decade. See, everyone keep quiet.
It's 20.
To be a technician, very basic thing, you have to answer right away.
For everything, first
20 dB.
That will be telling you that came in 10. That means when you increase the cutoff frequency 10 times, output will be down 20 dB. Now, I given you the example here. 1K, so in here 10 times will be 10K. Okay, so if I given you V in 10 volt, okay, so I know what V in, V out at minus 3 dB. And what V out at minus 20 dB. You can answer me, do calculation, and telling me what input is 10 volt. And I want to know V out at minus 3 dB. What V out equal? Gee, no one can answer that. Hopefully in the future, we can ask you, you can answer, let me know right away.
Did you ask for minus 3 dB? Is that what the first one you asked for?
Yeah, that V out at minus 3 dB. That means
7.07 volts.
exactly. In order to do the calculation, you take 10 volt time the number equivalent to minus 3 dB means 0.707. That's why you can get answer will be 7.07 volt. Correct. And the second question, at what V out at minus 20 dB. If the thing is you are not understand that thing, how come we keep moving?
1 volt.
0.1, I believe. Minus 10 dB would 1/10, and then 1/100th
Okay, now
at 20.
I can tell you, you get a 10 volt, right? Time, what number equivalent to minus 20 dB?
0.1.
0.1. That given to you.
1 volt, yeah.
So 1 volt, correct?
Yeah. If you can understand quickly, you know, a few more years, you can be engineering, I guarantee. Okay, so they can ask in VL at minus 40 dB, okay, or VL at minus 60 dB. And we have to know how to do calculation. Okay, so I will be stop my lecture here. Okay, Mr. Sam.
Yes, Mr. Pham.
Ready for the quiz?
Yes, sir. Ready to go.
Okay, just me stop that one.
Okay. All right, folks, make sure you download the quiz number 7 from the website. And we're gonna get started. All right, let me see. All right, share the screen.
Real quickly, how many questions is it for the whole test?
You will see it when you get to download the quiz. About the same as usual as before. Okay, here we go. Okay. Okay, so that's pretty much it. So make sure you upload it to the website before 12 noon tomorrow. All right?
Mr. Pham, can I ask Mr. Sammy, can I see 7, 8, and 9?
7, 8, and 9. It'll be 1
Please.
second. Okay, let me end the
Thank you.
slideshow. 7, 8, and 9.
Thank you.
Welcome. Okay, so that's pretty much it. So make sure you upload it before 12 noon tomorrow. Okay.
Sam, can
Thank
give me-
you, and we'll see everyone in the lab tomorrow.
Sam, can you give me the answer to 35?
Sure. The answer is 35. Okay, thank you, everyone.
Okay, bye.
Back to you,
Sam.
Mr.
Thank
Pham.
you, everybody.
Okay, we'll be see you guys next week.
Okay.
Okay.
Night.
Thank-
Okay.
Thank you. Good night.
Good
night.
night. Good night.
Bye.